Today, we're going to be undervolting and overclocking the RTX 3080 Founders Edition. A traditional overclock cranks the voltage, power limit, and fan speeds for maximum performance, but the 3080 FE runs hot out of the box. This guide, instead, will focus on increasing clock speeds while reducing voltage, giving a balanced overclock. This guide will work with any 3080, but if you're lucky enough to get a beefier cooler like the MSI Gaming X Trio, consider using higher voltage and power limits than I do because your cooler can handle it. To begin overclocking, you'll need MSI Afterburner to change clock speeds and GPU-Z to measure voltage and temperature. Both tools are linked in the description. I'm also using 3D Mark Port Royal as a ray tracing benchmark and Unigine Heaven as a rasterization benchmark, but you can use any game you want as long as the GPU usage is around 100%. Alright, let's get started. The first step is to undervolt the core. At stock settings, the card will run at roughly 1.05 volts and will be power limited in nearly every workload. To reduce power consumption, think back to physics. Power equals voltage squared over resistance, so reducing the voltage by a factor of 2 will reduce the power by a factor of 4. We want to undervolt the card to free up some extra power for higher clock speeds. We can limit the voltage using MSI Afterburner's voltage frequency curve editor. Press Ctrl F to open this editor. Each point on the graph represents a power state that the card can choose to run at, for example 1965 MHz at 1 volt. Now hold Shift to select all power states above the target voltage and give them a negative offset. Applying these settings limits the voltage since the card will ignore power states with higher voltage and lower frequencies. I applied a voltage limit at intervals of 25 mV to see how it affects power consumption of both ray tracing and non-ray tracing workloads. Since I mostly play rasterized games, and the stock TDP for this card is 320 watts, I chose 1 volt as my limit. Again, if you've got a third-party card or don't mind the extra heat, you can choose a higher voltage limit and also increase the power limit by up to 15% in MSI Afterburner. Now the card can pull up to 368 watts, but I prefer to keep mine at 320. In the end, choose a voltage limit you're comfortable with, in my case 1 volt, and apply the changes in MSI Afterburner. Now for the time-consuming part, overclocking the GPU core. We're going to be looking for the highest frequency offset at every voltage along the curve. I recommend setting the power limit to plus 15% for this part, even if you'll be dropping it again later. This helps the card actually reach the clock speeds you're going to be requesting. Start by opening the frequency curve again, and press L to lock the voltage. Open a 3D workload like Unigine Heaven and offset the frequency in increments of 15 MHz until the application becomes unstable or crashes. From my experience with this card, when you reach a clock speed that instantly crashes the workload, a stable overclock would be between 45 and 60 MHz below this point. For example, if I instantly crash at 1 volt plus 165, it'll likely be stable at just plus 105. If you want the best overclock, you can validate each offset with a 30-minute stress test. For time's sake, I prefer my heuristic of dropping the offset by 60 MHz. Once you find the highest stable offset for a given voltage, move over 25 mV and repeat the process, again locking the voltage with L. The in-between offsets can be filled in using the offsets from either side. Note that while doing this, the frequency curve moves up and down based on temperature, so only pay attention to the offset value. Here's what my final curve looked like. At lower voltages, I could run a plus 150 offset, but at higher voltages, I could only manage plus 120. Depending on your exact card, you may get higher or lower offsets than me. Before moving to memory overclocking, it's worth testing 4 to 5 different workloads, including one with ray tracing, to ensure stability. If you crash, just reduce the offsets. Since the 3080 has error-correcting memory, overclocking is a little difficult because you won't see artifacts or crashing. Instead, you'll see a performance drop when the memory starts correcting errors. Use MSI Afterburner to offset the memory clock in 50 MHz increments and look for performance drops. At around plus 600 MHz, I notice a slight decrease in FPS, so to be safe, I drop the offset to plus 500. Again, you could probably get closer to the limit, but I like having some buffer between my overclock and the point of instability. Now, onto the results. All tests were run with 3 configurations: stock, plus 15 power limit, and my full overclock. The 3080 was paired with a Ryzen 3900X, and all benchmarks were run at 1440p max settings. The first test was the synthetic ray tracing benchmark Port Royal. Here, increasing the power limit yields a 2.5% higher score, while my overclock performs slightly better with lower power consumption. The performance uplift here is overall pretty small and not at all noticeable when watching the benchmark run. Moving on to CSGO, we have much of the same story. This game is notoriously CPU bottlenecked, so it makes sense that the overclock only improves performance by 2.8%. Since all three configurations achieved over 400 FPS, I'm really not worried about the small performance uplift. Our first game to see a large improvement is Deep Rock Galactic running in DX12 mode. Not only did the average frame rate increase by 22%, but the 1% and 0.1% lows also improved greatly. These results shocked me, so the test was run multiple times, and I got the same result every time. Since DRG seems to be really power limited, I think the undervolt helped unlock quite a bit of extra headroom. Next up is another ray tracing title, Battlefield 5. This game runs okay with ray tracing enabled, but there's a great deal of micro stutter. The overclock slightly improves the 0.1% lows, but not enough to completely remove the stutter. Otherwise, performance is basically identical with and without overclocking. The bottleneck is likely in the ray tracing step, which this overclock has very little effect on. Killing Floor 2 is another game that saw massive improvements from the overclock. When running with NVIDIA Flex on its highest setting, the overclock improved average frame rate by 20.8% and the 1% lows by 19.2%. My overclock nearly doubles the uplift in performance from a plus 15 power limit, but only uses the stock 320 watts of power. The 0.1% lows are irrelevant because the first Z time of every game causes major stutter, which really dictates these values. Overall, Killing Floor 2 gains a lot from this overclock. Next up, we have the popular racing game Dirt Rally. This game sees another typical 4% uplift in average frame rate, but sees a massive 95% uplift in 0.1% lows. This test was repeated twice with the built-in benchmark, and yielded the same results each time. Improved frame time consistency could have something to do with the memory overclock, but I really have no idea why it did this well. Moving on to another racing game, we have F1 2018. This game is a special case where the stock voltage is much higher than the other games I tested. Because of this, the voltage cap prevented the card from reaching the optimal power state. The average frame rates remained constant across all three modes, while the 1% and 0.1% lows were slightly worse when undervolted. To resolve this, you can continue the overclocking procedure up to 1.05 volts, but that may hurt performance in other games. The final test involves professional rendering in Blender. The BMW and classroom scenes were rendered using the Cycles renderer with NVIDIA Optics Acceleration. Both scenes rendered around 3% faster with the overclock enabled, which could save some serious time on a multi-hour render. In conclusion, most games saw performance improvements of around 3 to 5%, but some games saw a huge improvement. Undervolting seems to make the biggest difference in games that are heavily power limited, as it frees up extra power, allowing the core to boost higher. So is overclocking your 3080 worth your time? I think it is, because you never know if the game you're playing will get a 3% boost or a 20% boost. Overall, an undervolt and overclock combination can improve performance while maintaining constant power consumption, thus improving efficiency. If you're lucky enough to get your hands on a 3080 in the next few months, I wish you the best of luck overclocking and hope you get some nice FPS improvements.